In this video, I will explain what is meant by statically determinate beam and statically indeterminate beam. We have three equilibrium conditions basically. That is, the first condition is summation fx is equal to 0 or summation h is equal to 0. The second equilibrium condition is summation fy is equal to 0 or summation v is equal to 0, and the third equilibrium condition is summation m is equal to 0. So if the beams have three unknowns, then with the help of these three conditions we can find the solution. If the beam is having only three unknowns, we can find the solution with the help of these three fundamental equilibrium equations. Then the beam is called as statically determinate beam. That means the beam should have unknowns is nothing but the reactions. Unknowns are nothing but the reactions. If the beam is having only three reaction and I have three equilibrium condition, then I can get the solution for that problem, and that type of beam is called as statically determinate beam. So I will explain this concept with the help of these examples now. Now, if I look at the first beam, the simply supported beam, it is simple supported at A and B, so it is having one reaction at A and having one reaction at B. Totally it is having two reactions. And I have three equilibrium conditions. And I have three equilibrium conditions. And I have only two unknowns. So simply supported beam is statically determinate beam. The second example is cantilever beam. Cantilever beam having three reactions at point A because it is a fixed end. Fixed end produces three reactions. One in the vertical direction, one in the horizontal direction, one is the moment. So totally it produces three reactions. And I have three equilibrium conditions. So three unknowns, three equations. So it is also a statically determinate structure. The next example is a propped cantilever. Here we have four unknowns because since A is a fixed support, one reaction, two reaction, three reaction, then this is the fourth reaction. So totally this is 3, this is 1. Totally we have 4 reactions, and I have only three equilibrium equations, so it is statically indeterminate. Beam. So proper cantilever is statically indeterminate. Then if I come to the overhanging beam, so at point A we have two reactions, point B one reaction, totally three reaction. Equilibrium 3, so this is a statically determinate structure. Similarly, double overhanging also a statically determinate structure. Then if I take a continuous beam, we can see that at point A we have two reactions because it is an hinge support, one reaction roller support, one reaction simple support, hinge, two reactions. So totally we have 1 plus 2, 3, 4, 5, 6. So totally we have 6 reactions. And we have only three equilibrium equation. So this is statically indeterminate structure. So fixed beam we have again 1, 2, 3 reactions, 1, 2, 3 reactions. So totally this beam is having 6 reactions, and I have only three equilibrium equation. So this is a statically indeterminate structure. So once again I will summarize the things. Simply supported, it is statically determinate. Cantilever is a statically determinate. proper cantilever is statically indeterminate, overhanging is statically determinate, then continuous beam is statically indeterminate, then fixed beam is statically indeterminate. That means the beam in which is having more than three reactions, the beam in which is having more than three reactions, that is statically indeterminate, because it cannot be analyzed by using the three fundamental equations of equilibrium. If the beam is having less than three reactions or equal to three reactions, then it is statically determinate structure. Thank you.